The floor looked fine in December. By August, it was tenting up in the middle of the living room, planks separating at the joints, the surface rising in a ridge no baseboard could hide. The installer blamed the product. The product manufacturer blamed the installer. The actual cause was physics, and it was predictable down to the millimeter. Vinyl flooring, luxury vinyl plank, luxury vinyl tile, rigid core SPC, is a thermoplastic product. Its primary structural component is polyvinyl chloride, and PVC expands when it gets hot. Not warps, not absorbs moisture the way wood does. It physically gets longer and wider as temperature rises, and it contracts when it cools. This is not a manufacturing defect. It is a material property, and every installation standard written for vinyl flooring is built around managing it. The Resilient Floor Covering Institute, the RFCI, publishes installation guidelines that govern vinyl flooring across residential and commercial applications. Those guidelines, along with ASTM F3261, the product standard for rigid core vinyl planks, establish the framework that manufacturer installation instructions are written against. The Florida Building Code defers to those manufacturer instructions as the binding installation requirement. That means when a manufacturer specifies a temperature window and a gap dimension, that specification carries code weight. Here is what the physics actually looks like in a Florida home. PVC has a coefficient of thermal expansion of approximately 50 to 68 millionths per degree Celsius. For a rigid core SPC plank, where stone powder is compounded into the core to increase dimensional stability, that number is lower, but still significant. At standard industry figures, a vinyl floor can move up to 1/4 inch per 100 feet of run for a 20 Fahrenheit temperature change. A typical open-plan Florida living area runs 40 to 50 linear feet. That is up to 1/8 of an inch of movement per temperature swing in a single room. Now consider what drives that temperature swing in Florida. On a summer afternoon, direct sunlight through a standard low-E window can raise the floor surface temperature to 140 degrees Fahrenheit. In an unconditioned space, a home under construction with no active HVAC, ambient air temperatures routinely exceed 100 degrees. The delta between a January morning and a July afternoon in a Florida home can exceed 60 degrees Fahrenheit at floor level. That 60-degree swing means the floor installed at 72 degrees is trying to expand by more than its perimeter gaps allow. When it runs out of room, it pushes up. That ridge in the middle of the room is compressive force with nowhere to go. The RFCI guidelines and ASTM F3261 address this with two controls. First, expansion gaps. At every wall, every cabinet base, every fixed object, including kitchen islands, fireplace hearths, door casings, and bathroom vanities, a minimum gap must be maintained. For rooms up to 50 feet in any direction, that gap is at least 3/8 of an inch around the full perimeter. For rooms between 50 and 85 feet, the gap increases to 1/2 inch. For any installation space expected to exceed 100 degrees Fahrenheit, a sunroom, a Florida room, a space without reliable air conditioning, the minimum gap is 5/8 of an inch. These gaps serve no function if they are subsequently eliminated. Baseboards nailed through the finished floor surface pin it to the wall and eliminate the gap. Transition strips that clamp the floor edge rather than floating above it eliminate the gap. Grout or caulk applied to hide the gap eliminates the gap. Any fixed element that contacts the edge of the floor field removes the expansion clearance the system depends on. Transitions must be fastened to the substrate only, never to the floor itself. Second control, acclimation. RFCI guidelines require the installation environment, the room, the subfloor, and the flooring material itself to be maintained between 65 and 85 degrees Fahrenheit for a minimum of 48 hours before installation begins, throughout the installation, and for 48 hours after completion. Flooring installed in a 95-degree unconditioned space, then cooled down to 73 degrees once the HVAC is commissioned, will contract after installation. Flooring installed at 68 degrees that subsequently reaches 130 degrees through a glass door in August will expand beyond any gap sized for normal conditions. In both cases, the floor was never given the baseline state the system was designed around. The gap is not a cosmetic detail. It is the only mechanism the floor has to accommodate movement it cannot prevent. Florida's climate pushes vinyl flooring harder than most of the country. The installation standards know this. The floor fails when the installer doesn't. Share this with anyone who's about to start a vinyl floor installation and subscribe for the next section. Drop a comment.